Hi, this is Jason Gossett again. So I'm here for the Interactive Advanced Concepts presentation for week 3, module 3 of our Gen Chem class. So what we're doing this week is we're told to mix baking soda with vinegar. So baking soda is considered a weak base and vinegar is considered a weak acid. So looking at some of what our textbook said as well as a little bit of extra research just to kind of fully understand the topic, what we expect to happen with a weak base and a weak acid is a pretty drastic reaction, and that is due to multiple things going on. So for one, the base, which in this case again is the baking soda, we're expecting that it's going to try to take a proton from the acid, and then when that happens, looking at some of the research, it basically should create both carbon dioxide gas as well as H2O or water in the solute or the solution from the reaction. So whereas if you had strong acids and strong bases combined together, they would fully what's the word I'm thinking? Disassociate and kind of neutralize and become separate ions. So it'd be a little bit more of a stable reaction from what I've read. So again, we're going to put the baking soda in and then pour the vinegar in it and see what creates. But what we're expecting is that it creates that carbon dioxide gas from the reaction of these two substances or solutes to then create the carbon dioxide gas and the H2O. So it should be pretty drastic. So I'll start by putting some of the baking soda in a paper towel. Sorry, I got this out of the freezer, so it's kind of hard in there. So that's probably good enough for now. And basically just wrap it up in this paper towel. Put it in there, and then I've already pre-poured some vinegar just because it was pretty full of just some white distilled vinegar. So we're gonna pour that into here and see. We have this lid close by just in case. So I hear it fizzing. Doesn't really seem to be doing as much as I would have thought. It could be, maybe I need a little more vinegar. I'm honestly wondering if I did it without the paper towel, if that would actually, here I'll just pour some baking soda in without the paper towel. And that was apart from what we're told to do, but I'm gonna try it and see. There we go. So there's that gas and H2O being created and reacted. So you can see, basically it's creating that unstable or extreme reaction pretty much. It's ironic, you can actually start to not smell the vinegar smell as strong too, so I wonder if that's part of the water or H2O that's being created, kind of taking over that some of that smell. Like it's actually not bad at all. So anyway, I do know, I remember back in like elementary school, this is pretty similar to how we would create volcanoes for science projects. And you know, you didn't really think about it back then as a little kid, you just think, hey, this is really just kind of cool that it does this, but it's good to kind of know the why behind it now, with the fact that you're using weak acids and weak bases creating that extreme reaction. So anyway, I think the limitation there was just the paper towel was covering up, or maybe I didn't put enough baking soda in it, but thankfully with just pouring it in there, we were able to see what happened. So thanks. So I'm actually here back again just really quickly. In my video, originally with the paper towel, we didn't see the reaction occur, so I just had to pour some straight into the vinegar. Well, as I was going to pour the vinegar, or I guess the reaction down the drain, when I poured it or started to pour it, it actually started to react again with the baking soda inside the paper towel. So you can kind of see all that trapped gas inside the paper towel, which I would presume to be that carbon dioxide gas. So anyway, I think again, just the paper towel somehow it maybe wasn't fully submerged and it didn't react well enough. But there again is just another example of the reaction happening.